My name is Kevin Wafula. This is a short presentation for my Cycle 3 project that is part fulfillment of the Security Tool Development course number CSC 842. That is also part fulfillment of the PhD in Cyber Operations program at Dakota State University. This is the summer 2023 class, and the professor for this course is Dr. Cody Welliu. Quick overview. If you come to my GitHub, you'll read about the tool overview, which I'll go into a little bit. Why I chose the tool. So you'll need to come to this landing page and go to the Cycle 3 folder. Quick overview, why you should care, the interest in the tool, 3 main ideas I can share, and then the technical requirements of the tool, the installation of the tool. Actually, I need to change this to show that this is installation, that is technical requirements. My apologies on that. And then the topology of my lab setup and the instructions how to install everything if you want to replicate this lab environment and play with the tool itself and even extend it. That said, real quick, my purpose for going this tool was that when I was looking at ARP protocol attacks and how they're detected, I was just generally looking over a lot of protocols, so I zoned into ARP. I found these tools out there, but others have built a proof of concept, but they're all basically agent-based ARP spoof and man-in-the-middle attack detection tools. They're basically host-based intrusion detection systems. So I chose to extend this work and say, let me go take it from the approach of a network-based intrusion detection system that can protect an entire subnet, an entire network. And that's what I did. So quickly, just to go over the tool, it leverages a DHCP server, in this case, key DHCP server, and we register DHCP reservations IP addresses to MAC address mapping one-to-one, right? DHCP reservation. And that becomes the authoritative source for the IDS to say, hey, this MAC address belongs to this IP address, or vice versa. So in this setup, the Kali Linux is going to be the attacking system. The IDS is going to be running the key DHCP server and the Scapy Python tool that I've built. And we're going to be attacking this Ubuntu server over here. So this is just a setup. So without further ado, let me jump into the demo and show what we have. So if I come here to our IDS system, we can see that is at 2.4, and the MAC address ends with 5878. If I quickly log into the victim system, the Ubuntu system, and clear the screen, we can see that the Ubuntu system is at 2.2 and the MAC address ends with CD. We come to our router here. We know that the router is ending with it's an IP address 2.1, but the MAC address is let's go ahead and type ifconfig. The MAC address ends with E.2, right? And our Kali Linux here is 2.3 and the MAC address ends with CE. So take note of that MAC address. So quickly on a victim system, let's look at what the cache, what it has in ARP cache. It knows the gateway is .1 and is at MAC address ending with E2. And then if we come to the router here and do the same ARP cache check, it knows that the victim system is at 2.2 and MAC address ending with CD, not CE. Take note of that. So I'll go ahead and launch here EtherCap. I already pulled it up and launched it. There's a video that on the GitHub repo that shows you how to use EtherCap. So I'm gonna go ahead and do a scan of the network. It's going to identify all the different systems on the network so we can pick which one we want to attack. So immediately we found these two systems. So I'm going to set our Ubuntu server at 2.2, right, as target number 1. I'm going to set our router as target number 2. And if I come to targets, I can see that they're already set. So far, no connections of interest. So the targets are set. So I'm going to go ahead and launch the ARP poisoning. Before I do so, let's kick off the IDS system script and talk about it. So what the IDS system is doing here, and I try to make it more verbose so I can talk through it. It kicks off and initializes an IPAM database, SQLite database in memory. Basically creates it. It goes ahead and reads the DHCP server leases from this server file and dumps them into a JSON file that we're going to use to populate the database. Quickly, let me show you the DHCP server running. So we have the key DHCP server running on this system. And then if I read the lease, right now there's nothing on the lease. I'm going to read again, and you can see something has registered, right? The request, these systems are requesting for IP address .2.3. So back to the script. So once it reads the leases, it dumps in JSON file, and then it loads those leases into memory. So I'm just dumping what is reading the memory here. And it's going to go ahead and read this in a loop so we can sync the in-memory database with the DHCP server lease reservations. So, and you can see right now it's just registering them, into memory. I'm comparing what it's reading in the file and what is in the IPAM database memory. So it does this a couple times, and once it's done, it starts the IDS engine. The engine sniffs a packet, and then here's the Ethernet header, and here's the payload. And basically, in this ARP response, this system is saying, hey, I'm MAC address 5878. I am at IP address ending 2.4. And we see, if we come down here and say, we don't see that that is our system here. This is the IDS system itself. But you'll see with other messages when we start detecting them. But basically, that's the sniffed packet, and this is what is in the IDS database memory for comparison with that packet to see if there's an attack. So far, there's no attack happening. We can see everything's coming back clean. Nothing's happening. A good example is this one here. This is the router. It's saying, hey, I'm at MAC address ending E2 and my IP address is .1. And we come here the database here, that is indeed true. This is the PMSense firewall router. So that's basically the IDS. So the IDS is still running, it's not detecting anything. So let me kick off this ARP attack. And right away, we can see that the IDS has detected an attack. Let me explain the attack again. Let's walk through it. On what I call the left-hand side of man in the middle attack, the MAC address ending CE, which is Kali Linux, is telling the server that it is 2.1. That is not true. This MAC address is actually 2.3 based on this table. But it's trying to tell the server that it's 2.1. So the engine, the IDS engine, detects that and says, hey, there's a poison attack that's happening. On the right-hand side of the man in the middle attack, I guess that was the left, this is the right, it's telling the router that, hey, I'm the Ubuntu server. Ubuntu server is at MAC address this. If you want to talk to Ubuntu server .2, it'll MAC address this. We know that Ubuntu server is a MAC address CD. So you can see that, again, it's detecting that. So To finish the video, let's go back into the systems and look at the app cache. You can see now that previously this system knew that MAC address ending with E2 was the router, but now it's seeing the Kali Linux as the router, right? IP address 2.1. If we come to the router here and do the same, previously 2.2, which is Ubuntu server, was at MAC address ending with CD, but now 2.2 is a MAC address ending with CE. So you can see that the Kali Linux has taken over. And just to finalize the video, let me go ahead and ping the Google DNS server and see the Kali Linux here registering that. And you can see Kali Linux has registered that communication. So basically, Kali Linux has taken over the communication and is relaying back and forth unbeknownst to the Ubuntu server. So that's basically what I was trying to achieve with this script. The main difference with what's out there versus what I did was that I'm leveraging a DHCP server reservation IP addresses as the authoritative source. I'm loading those into the IDS engine in its SQL database memory. And then I'm comparing that against this copy sniffed packets for app messages to see if there's an attack. Thank you very much for watching. I hope that you enjoyed the video, you learned something. Go ahead and look at my repo. If you're interested, download the tool, follow the instructions, set up a similar environment, play with it, and hopefully extend it so others can also learn and benefit out there in the community. Bye-bye.